Now in example 6, what we have is a situation where when we look at the left side, it definitely has more terms involved. But the right side also is being squared, which we know will produce more terms, and also it's got cosecants and cotangents, which I kind of regard as more complicated than just sines and cosines. So what I think I'm going to do is go ahead and start with our right-hand side. And so as I'm starting with the right-hand side, I'm realizing that when I'm going to square the cosecant minus cotangent, right, I'm going to have to FOIL it out. So this will be cosecant x minus the cotangent of x times itself. And of course FOIL, so first times first gives me cosecant squared x. And then the outside, minus cosecant x cotangent x minus the cotangent of x times the cosecant of x, and then finally plus the cotangent squared of x. And then in the middle here, these two terms we can recognize are the same. So this is cosecant squared x minus 2 cosecant x cotangent x plus cotangent squared x. Now, while one of our rules is to write our cosecants, cotangents, and things like that in terms of sines and cosines, the reason I held off here is because I realized I had to FOIL things out, and having cotangent be cosine over sine as I was trying to FOIL would have just made things even more complicated. So I waited on that, but at this point I think it's appropriate. Over here I don't see any cotangents or cosecants, so I know I'm going to want to get myself into the language of sines and cosines. All right, so my cosecant squared here is 1 over sine squared x. Cosecant is 1 over sine x. Cotangent is cosine over sine. And so one nice thing that's happening in this problem is that we do have the same denominator all the way around, sine squared x. So I can immediately write this all as one single fraction, which is good because the left side has one single fraction. So this will be 1 minus 2 cosine x plus cosine squared x, all divided by sine squared x. Now let's think about what we've got going on here. We know that ultimately we want just cosines in the bottom. We don't want sine squared in the bottom. So let's think about how do you replace sine squareds with cosines, right? Well, we do know that taking the Pythagorean identity and subtracting cosine squared from both sides of it gives us this equality here. So we can replace the sine squared on bottom with 1 minus cosine squared. And so at this point in the problem, this is where it's good to kind of start peeking at the other side and really, well, we've already done that, but do it again, right? You know that you've got to have a 1 plus cosine show up, right? And so you might ask yourself, okay, how does that happen in a problem like this, right? Well, in a problem like this, the only way I can get 1 plus cosine to show up is if it's a factor of that denominator, right? And so, well, if we remember our algebra rules where, when we have 1 minus x squared, right, that becomes 1 plus x times 1 minus x. So what I'm going to do is I'm going to write my 1 minus cosine squared as 1 minus cosine times 1 plus cosine, right? This is a difference of squares, and a difference of squares always factors in this manner. So that's good. We have the 1 plus cosine showing up down here, 1 minus cosine showing up also. So we know that this 1 minus cosine's got to go away. So then the question becomes, does this factor? Well, here you might say, well, is there any way to factor it so there's a 1 minus cosine so that way we can get our cancellation? The answer is yes, right? To make the 1 here in the first, I better put a 1 right there. To make plus cosine squared here, I better put a minus cosine x, so negative cosine times negative cosine is positive cosine squared, and then the outside and insides add together to make this. So that's exactly how it factors, and then we can cross those out. So then this becomes 1 minus the cosine of x over 1 plus the cosine of x, which is in fact our left-hand side.